And we are back with practice number 2. So now after practice number 1, just working on mole to mole ratios, now we're going to actually use mole to mole ratios to change moles of chemical A to moles of chemical B, or moles of chemical B to moles of chemical A. So let's look at a practice problem here. It says, consider the unbalanced chemical reaction. So step 1, the reason there are gray boxes here is because we need to balance it. So let me quick balance it. There's 1 mole of iron on the reactant side, 2 moles of iron on the product side. I'm going to use a little pen here. So now we have 2 moles of iron equals 2 moles of iron. Oxygen, 2 moles, 3 moles. So I'm going to write a 3 here. That would make 6 moles of oxygen. And I'm going to write a 2 coefficient 2. That would make 6 moles of oxygen here. But by writing a coefficient of 2 here, I've now doubled the moles of iron. So now there are 4 moles of iron, which means we need to put a 4 here. And I will trace over it. 4 moles of solid iron reacts with 3 moles of oxygen gas to yield 2 moles of iron. Let's see, that would be iron 3 oxide. That is iron with a +3 charge. So that's iron 3 oxide. Now we have the balanced equation. Now we know how many moles of iron are needed to react with how many moles of oxygen gas to yield how many moles of the product, iron 3 oxide. So letter A asks us to, after balancing it, to write 3 mole to mole conversion factor. So I'll just start here with iron. 4 moles of iron is equal to 3 moles of oxygen. Right? We just made a ratio out of these 2 chemicals. What about these 2 chemicals? We would write 4 moles of iron is equal to 2 moles of iron 3 oxide. And what if we write a ratio, conversion ratio for these 2 chemicals? We would say 3 moles of oxygen gas is equal to 2 moles of iron 3 oxide. So there we have 3 conversion ratios. Now we could do more. We could flip all of these upside down and then have 6 of them. But we've got 3 mole to mole conversion ratios. Now we're going to use these mole to mole conversion ratios to solve problems. Let me double check, make sure we are in the field of view. Perfect. All right. Letter B says, calculate the number of moles of iron 3 oxide produced. So we want to know how many moles of this is produced. How many moles? If 5 moles of oxygen gas, 5 moles of oxygen gas are fully reacted. Okay, so let's do this. If we look at our molar conversion triangle of science, they want to know, we're going to start here, chemical A. They give us moles of chemical A. Moles of chemical A would be oxygen. So they tell us, all right, we have 5 moles of chemical A, which is oxygen, and they want us to change that to moles of chemical B, and chemical B here is iron 3 oxide. So we're going to start at moles here, and we're going to change to moles here. And the conversion ratio we're going to use is this one. We just follow the, there we go. So we just follow the arrow. We want to follow this arrow, so we're going to multiply the moles of chemical A, which is oxygen gas. We're going to multiply those moles of oxygen times, we're going to put moles of oxygen on the bottom, and we're going to put moles of our product on the top. So given is 5 moles of oxygen. That's the given. And remember, we can write it over 1 to make it a fraction. Now, we're going to multiply that by the mole to mole ratio. That's what I meant when I mentioned multiplying it by this conversion ratio. We're going to put moles of oxygen on the bottom, and on the top, we're going to write moles of the product, iron 2 iron 3 oxide. Now, what numbers do we put here? That's these numbers. The mole to mole ratio comes from the balanced equation. 3 moles of oxygen is equal to 2 moles of iron 3 oxide. Now we can cancel units. Moles oxygen on top, moles oxygen on bottom. The only units left here are moles of iron 3 oxide. And then we do the math. That would be 5 times 2 is 10. Divided by 1 times 3 is 3. So we end up with 3.33333. But let's look at significant. So let's look at significant figures. This 5 is actually 5.0. So this right here, 5.0, that's 2 significant digits, and that's what we're going to round to. We need 2 significant digits. 5.0 is a measurement of oxygen gas. The mole to mole ratio is not a measurement. So mole to mole ratios are not used when figuring out how many significant digits to round to. So we're just going to round to 2 significant digits. So 3.3. And that is our answer. So typically 3 moles of oxygen gas makes 2 moles of iron 3 oxide. But if we go up to 5 moles of oxygen gas, we go up from 2 moles to 3.3 moles of iron 3 oxide. All right, let's try another one of these. Letter C. It says calculate the number of moles of solid iron. So they want solid iron. So this is what we're trying to figure out this time. And we want moles to produce 8.9 moles of solid iron 3 oxide. So this time, if we want to make 8.9 moles of iron 3 oxide, the question's asking, how many moles of iron do we need? Now, I can actually predict it. I can do it in my head without doing the calculations, because 4 moles of iron make 2 moles of iron 3 oxide. Right, so twice as many moles of iron are needed to produce iron 3 oxide. So then I know that the answer is 8.9 times 2, right? Because I need twice as many moles of iron to make iron 3 oxide. So if we want 8.9 moles of iron 3 oxide, we would need double that, which would be 17.8 moles of solid iron. But let's do the problem here. I'll switch colors since I wrote it in orange. So we start with what's given. 8.9 moles of iron 3 oxide. Then, if we look at the molar conversion triangle of science, now this time we're starting at chemical B. We're starting at the product and we're going back to the solid iron. So now we're going to multiply by this conversion ratio. We're going to put moles of chemical B where we're starting on bottom. So moles of chemical B is iron 2 oxide, and moles of chemical A is iron. And what's the mole to mole ratio? 4 moles of iron is equal to 2 moles of iron 3 oxide. Now we can cancel moles of iron 3 oxide, moles of iron 3 oxide. The only units left here are moles of iron. So 8.9 times 4 would be, we could put that in a calculator, but before we do that, I'm just going to simplify here. 4 and 2, I'm just going to make that 2 and 1, right? So 4 and 2, I can simplify this ratio. 4 to 2 is the same ratio as 2 to 1. So we have 8.9 times 2, that would be 17.8, but we need to look at significant digits. 8.9, these are 2 significant digits. So we need to round to 2 significant digits. 1, 2. So we're going to keep the 1 and we're going to round the 7. So we look next to it, 8. So we're going to round up. So the answer is 18 moles of solid iron. 18 moles of solid iron are needed to produce 8.9 moles of the solid product. So that's practice problem number 2. The one that's left, there we go. That's practice problem number 2. The one that's left for you to do on your own is practice problem number 3.